I think we could start, so it's time to start actually. My name is Anastasia Kazakova, so I'm working for the company named JetBrains, and I'm actually going to talk here about what the C++ looks like when you look at it through the glasses of language tool. And under the language tool, of course, I will have in mind IDEs mostly, but to be honest, I'm not going to show you any tool here at all, except for a couple of screenshots in one slide, so there will be no tool shown here, so sorry if you actually came here for that. I will be talking mostly about language itself and some tools in the ecosystem, but not in particular the tools that we do. So just before we start, a couple of words about my background so that you understand who am I actually, why I'm talking about these things. So if you ever take my business card at our booth, you could find there that I'm a product marketing manager for C-Line, our cross-platform C and C++ IDE. But the story is that I'm actually a C++ developer before that. So I was doing mostly embedded development, so in the network area. So I was working for some outsourcing company that was doing some residential gateways, routers, APTV, and all the stuff like that. So we were just having this embedded Linux on the devices and writing some code for that. And at that time, I was mostly Vim addicted. So because like on an embedded device, you're lucky if you have Vim. And I got used to it, and I was using it like all the day long on the usual machine as well. And I was fine with that because most of the time we had some small files and nothing like smart really was needed for us at that time. And then I came to the company where I wrote some maybe more high-level code that's more about logic that works in the networks like 3G, 4G, LTE, WiMAX networks, and we were just coping with the user's policy and all that stuff, and it was in C++ as well. And that time I just, that was actually the first time I met a real IDE for C++, and it was NetBeans, so that was just my first IDE for C++. And I was on Linux, and I was like searching for a good tool for quite a long time. I tried a lot, and I was like a little bit surprised that there are not that many actually on the market. And then I learned that the JetBrains, the company that I actually knew for a very long time before that, just started doing the C++ IDE, and I just decided to join the team to be not the person who is actually developing, but is very close to development on the real tool and is like talking to C++ developers about the tool and trying to understand them and to pass these problems to the team and back. So that's about my background, and coming to the topic. So before I start, I would like to talk about this triangle a little bit, because from my point of view, so these three things are strongly connected. So we have a developer, we have a language that this developer is using, and we have tools. And I do believe that all three, they have a common goal, and they just couldn't exist without each other. Because like if we talk about the language, so the developer is actually selecting a language for his tasks, and I do believe that there is no language for every task, that every area has its own language. And so the developer is actually selecting a language, and while using this language actually needs tools, because if you look at what the language has, so for example, if we need to format the code properly, you couldn't do it manually. You just won't. You just skip this step. You will write the code as you can. So because, yeah, I believe that there are some people who could do that. Yeah, you know, like they are quite accurate. They are doing the things properly without any tools. They are magic. They are fantastic. But I don't believe we have many of them, actually. And so just to control if the things are done properly, some tools are actually necessary. And if you I would like you to remind that when the Pierre was actually introducing, for example, C++ core guidelines in 2015, his first actual step was that we need tools, because he understands that actually to support all that stuff, all that really good stuff that is there, we need tools that will be just controlling these things, checking these things. So, and actually the tools is here to serve for the developer, and they are actually here to support the language and to respect the language and to just help the developer to do his tasks. So, and if we look at the IDE, so just for you to better understand what is the reality we are actually facing. So if you ask anyone, so what do you expect from the IDE? So the first answer could be correctness, like the people are expecting that the IDE is fully correct in terms that it could understand the language 100% correct, and so there is no like false positives, there are no red code, whatever. So this is good, but if you think more, the second thing that you are expecting from the tool is actually the performance, because you could do a tool that is absolutely correct, but if you wait, let me say, I don't know, 5 seconds for a completion, that's absolutely unusable. You won't use it. You'll just throw away this tool and go to some other tool or to some text editor. The people are also expecting some smartness from the tools like IDEs, because they like saying that if I don't need anything, I could take a text editor. If I'm taking an IDE, I do expect that it do some things on the fly, like formatting the code or some code analysis, so at least showing me some proper completion and navigation stuff. The people are expecting that the tool is universal. That means that it could handle the whole project. So it doesn't work in terms of one translation unit or one file. It works in the context of the whole project. That means that if you are refactoring, for example, your project, it actually does the refactoring for the whole project. It doesn't rename your function in one file because it's absolutely useless. You will break the whole code. Like the people are expecting that the IDE is helpful and sometimes proactive, suggesting some things in advance. And of course, they ask to integrate as many tools as they could just dream about into the IDE. So, and if we take only the first 2 points from this list, you'll get our reality and how we look at it. Because for IDE, actually, correctness and performance, they are balancing each other in every moment in the lifetime of the IDE, because we need to find a proper balance. We need to be correct, and at the same time, we need to provide the performance that suits you, that is like okay for the user to use the tool. And for C++, sometimes this balance is very hard, because you could either provide a very correct tool that will be very slow and maybe not that smart, or you could provide a tool that is very quick but absolutely useless because it can't understand anything you write in C++. And so finding a good balance is actually a tough question. And this is actually the filter that we have in our glasses when we're looking at the language. This is always the thing that we have in the background. So talking more about our realities, so I would like to tell you one small story from my real experience. So while I was working for the outsourcing company, we once had a project where the company came to us and said that they had a project for some military guys or whatever, and they had some code that actually need to be certified. And to certify this code properly, they need to have some kind of a documentation. It's not a proper documentation, but what they asked for was a like a command for each line of reasonable code, not having something really smart there, but more or less the same code in some human-readable way. And of course, they asked us to generate these kind of commands because they had a huge code base and they need just to certify it, not spending lots of human resources on doing that manually. And we say, okay. And the code was in C++. And while I started doing that, I understand that actually it's quite hard because, you know, like there are lots of issues. We'll be talking here later about them. But we had, at that time, we had a good trick. We had an ability to come to this company and just say, please don't do that in your code. Or please don't write code in this way, do it another way. And that really saved us because we could just eliminate lots of problems and provide the tool that quickly provided them the documentation, they got the certification, everyone was happy, the project was paid, and for outsourcing company, it's just a win. So, but if you come to an IDE, that's not the thing we could do. We need to deal with tons of code. There is legacy code, there is code with modern standards. Quite often they are just mixed, and the people are doing lots of things, and we need to cope with these things somehow. And quite often there are even the situation when the people are coming and saying like, hey, I found this very nice feature that's not in the standard right now, it's just some technical specification, it's not yet decided, but I would like to use it in the IDE. Okay, so we need to do such things as well. We need to somehow cope with this code. And the last point here is the incorrect code. That is also very important because an IDE should actually go with the incorrect code as well. It could not just blows the whole project away while you are just writing some code and you just not finish the line. So you need to show the other parts of the code like they are correct. And so strictly speaking, the code is not correct until you finish your line. But for the IDE, you need to show it more or less in a good way. So you couldn't just stop parsing the whole code because the line is not finished. And here is the very important point, because the tool that is quite often the IDEs got compared to is a compiler. And that's true that they have lots of common things like compiler and IDE. But actually, they are different because they have different goals. So the compiler actually needs to compile your code to provide the output that you could run. But the IDE needs to provide you smart features, and that's the first point. It needs to like highlight your code properly, provide you completion, whatever you expect from an IDE. And it also, as I said already, it has the knowledge about the whole project, not one translation unit as a compiler does actually. And there is also this point about error recovery and handling errors. So, and for many years, actually, these just were two different like areas, and they were not intersecting. There is Clang right now that is like some step in between. So this thing that is coming from the compiler world to the IDE world, and I do believe that's really good. And I do believe it would come to the IDE world and would like solve many problems there. It's on the way, from my point of view at least. Not there yet, but quite close actually. So just a couple of more things, some philosophic one about why this talk actually. Just because, first of all, I would like to share our view here, so how we see the language. And this is important because if you know how the IDE works with the language, it could help you in many ways to understand the tools you have and maybe to understand what are the problems, what is happening actually there. I would also like to share some excitement about the new features that we're really in love with from the point of the IDE's creator, and to share some lessons we have here. And probably some things that I'm going to talk here will help you to have some kind of a better C++ code, because you will understand some shortage here. So before we really start, let's play some C++ game here. So let's take a look at the following piece of code. Very short one, very basic one example. And you see a very two very similar lines in the end of this test function. And so you could guess what is K and what is L here, if you look at the example. So actually, the lines are really looking very similar. But if you think about it more, you would guess and you'll find out that, so I just put some screenshots from the tool here, just showing the information that the tool has got from actual lines. So actually the first one is a template, and the second one is a binary expression. And they really look similar. Like, you know, there is no, if you don't see the upper part of this slide, there's just two similar lines. Okay, so one more example. Not that similar lines, they have some differences, but still, if you think about what is Y and what is Z, you could find out that the first one is just a constructor with a parameter, and the second one is just a variable Z of type X. But they also look very similar, and if you know nothing about X and Y, so you just know nothing about the code there. One more example of that type, really very short, so looks like that. So two lines that are nearly saying the same using this nice decal type. And if you just think about it, you'll get that the first one is the variable b of type int, and the second one is a cast of 0 to type of A. But they really look the same. I will play a little bit more in this game, and we'll show you this nice example. And the two lines at the bottom of the test function are really looking the same. But again, the first one is a cast, and the second one is an expression. And so if we end up with a game and think about what's going on here, so the story is that actually I won't be like talking here about context dependent, context free, or whatever. There is a very long discussion on Stack Overflow, like how we could properly call the C++. I won't dive in it at all. But what I would like to talk here is that to properly parse C++, we need to distinguish types from non-types. And actually, each example on the slide, on the previous slides, were just about that. So you need to understand if what you see is a type or not, and that actually affects all the following parsing here. And there is also this very nice example that I took from some from one PhD about C++ actually. That's the first line in the example is a list of declarations, and the second one is a list of expressions. And to understand that, you need to actually read the line up to the end. And the input could be infinite in terms that it depends like on the on how actually what's the length of the input you've got actually. So, and you need to read it up to the end to understand what was going on there actually for the whole line. And that actually what affects each C++ tool in a very deep way. So that's how the biggest thing we have to deal with. And the main idea is that actually the IDE, just because I was talking here that it tries to find the balance between correctness and performance, and to get better performance, what IDE actually does, it tries to postpone as much as it can for the later times, because like we will postpone this because the user doesn't need it right now, and we'll postpone this, and we're fine because we're doing mostly nothing at this point of time. But if we need to resolve quite a lot of things just to parse the code correctly, that's the problem. So if we talk about what actually affects, what actually this kind of thing affects. So first of all, there is highlighting and formatting that are happening just as you type. So if you just took any of the example that I was showing previously, like for example this with template and binary, like an expression, so comparison, you understand that to highlight it properly, you need actually to parse and resolve it correctly, because the user, for example, might have some like different highlighting for template instantiation and for some expressions. The user might have different formatting settings, because like usually the users are, for example, putting spaces like in between these angle brackets, and should I put them automatically in the IDE for the user, or should I not, because it's a template instantiation and the user doesn't need any kind of spaces. And these are the things that are happening just as the user types. So he doesn't like asked us for anything, but we had to do something at that point of time. So there are more things that could be invoked by the user. So they could be completion that is appearing just as the user types, or they could be a completion that was just invoked by the user. They could be some navigation action, whatever, lots of things. But at least these things could be invoked explicitly. But for example, highlighting and formatting, they are just, usually they are working automatically. And I should say that actually we do tools for many, many languages. So we have tools for Java, we have tools for Python, we have tools for JavaScript, Ruby, Scala, whatever. But the C++ was the first ever language when we faced the problems at this level. So we had some similar problems in Ruby, for example. It also has these kind of things. It also could provide such problems. We had some interesting things around Scala, but still, the C++ was the first time ever language when we actually understood that the problem is that big. If we talk about the actual code result and what it depends on, so there are actually three important things. First of all is the order of the definition. So, because in this example it's quite simple, so the first function call is just not correct, and the second one is okay because I have the declaration here. Then it goes to default arguments, that is a little bit more tricky. So, because the first one is not correct because it doesn't have enough arguments, and the second one is better because I have a default argument here. And actually for the IDE, we need not only to show that something goes wrong, but to show you the proper, the proper issue, so that these too few arguments. And there is, of course, overload resolution here. So, and overload resolution and sphinaya that Marshall was actually previously talking here, they are nice until you do an IDE. Let's come to the story about highlighting. Let's take the simplest operation that the IDE could do for you, highlight the code properly. And think about if we could just do highlighting with the lexer only for C++. And the answer is no, we can't. Why can't we? Because we have angled brackets, for example. Before C++ 11, this this construction was just ill-formed, because you either took the angle bracket as one token, or you could double angle brackets as like one token or two tokens, and the maximal munch C++ lexer takes took it actually as one token. And only starting with the C++ 11, we've got this information in the standard, like how to correctly parse this kind of angle brackets when there's a template instantiation or when it's just the greater than operator. And the problem is that an IDE, to highlight your code properly, actually has to follow these rules to understand what's going on there, to parse the code, to resolve the code, just to highlight the matching angle bracket for you, or just to close it, for example, automatically, or just whatever. And yeah, so this was about it. And then another example about highlighting with a lexer. This is a very nice code, actually, and what it says here is that I could not even highlight the keywords on the lexer, because public is a keyword until you do something like that. Because here I have a variable called public public. But how the IDE should know about it? It should understand what is X and understand that there's actually a variable. Because if it doesn't do any kind of work like that, it will just highlight as a keyword, and that's not what we are actually expecting here. Okay, yeah, I will take some time for Peter to take a photo.
I have to try that.
Some more tricky example here about code inspection and highlighting. And so the story is that I have two structs here. I have two declaration for function foo. One is taken S1, one is taken S2. I have two templates here, and I have that very line in the main. That is okay if I have S2, and that should fail if I have S1. Because in case of S2, I have a type here. In case of S1, I don't have a proper type here. So that's, again, the story that I need to understand if it's a type or not. And what we all are currently doing here, and I see it in your eyes, you're trying to understand what is written actually there. What you are doing actually is you are trying to understand what is the call foo with S2, what it returns, so what is the decal type, trying to take the template to put it there, and that's the work that the IDE should do here as well. All the thinking process that is happening currently in your head is the process that should happen inside the IDE, just to highlight that the code is correct or not. So if I put the S1 here, the IDE has to highlight an incorrect code for me. So it has to do all that stuff. So But the world is not that bad. And first of all, they hopefully will be concepts. And we, as an IDE, are really hoping for them, because for us, the concept means that all the information that could be hidden somewhere inside could be written properly, explicitly for us, and we could get some useful information out of it, hopefully. Sure.
Have you implemented the syntax already?
No. So we do hope for it. We're still waiting for the final decision. We like trying to follow all the technical specifications that we have. And we really do hope that this could save us from many things. Of course, there will be legacy code. Of course, there will be code that is not using the concept. But at least in some cases, it could be helpful. And moreover, like if we are talking about the concepts, so at least we could cache some information, and this will help their performance as well. So, and talking about concepts, actually, I would like to share my excitement that if you look at the C++ core guidelines part dedicated to templates, it's actually full of concepts. It's talking about concepts in each suggestion it has there, and there are just a few examples that I put here that it suggests to specify concepts for all template arguments. That is really wonderful, so you should provide all the necessary information. And there is a suggestion to use, to prefer concept over auto, because auto is actually the weakest concept we could have. And there are actually more, and I'm really happy with that, because if we could like suggest people to follow these rules, that means that the proper information could be provided. And that's not only actually about an IDE, because if you think deeper about what I'm talking here, that means that if you just read the plain code, these things could help you to read it in an easier way, to understand the code. And if you could read the code easier, you could maintain it easier, you could provide, like, to be safe from some errors in your code. And so these are really good things. And moreover, if you, like the C++ core guidelines, what I like about them is that they have this kind of an explanation why we need this rule. And if you check these explanations, in many, many cases, they start with the sentence that this increases the readability of the code. And actually, that's not only increasing the readability for you, it helps an IDE, and it helps in many sense. Talking more about the concepts here, so apart from the fact that it actually provides some additional information to the tool, and we could also, as I said, we could try and cache some information. So we could try and save some time and have some knowledge about the code that is stored somewhere. And also we can do some really nice things. For example, we could provide you some IntelliSense inside of templates. So the templates actually, while you're writing actually some code inside the template, we know nothing actually about what you are using there, in like at least in general sense, and that means we could not provide you any help, any support. So no code completion, nothing like smart for these template arguments. But if you have some concept that is, for example, saying that this function should be available and it returns that type, we could do something. We could like help you to provide you the completion, to show you that the type is not matching or whatever. So this could be the nice thing, and we're actually looking at concept right now and having so many good things in mind that we're really hoping more for the concept. Okay, so let's move on. So talking about C++ and having it in the IDE, so let's talk a little bit about functions. Why I'm actually talking here about functions is that actually, the story here is that function bodies, they have the most of the user's code inside them. So most of the code you're actually writing, it's inside the function bodies. And the function bodies are in ideal world. They are very nice because you have a function signature and you have some function body, and in the ideal world, it's this function body is quite independent. So you don't need to go into function body to understand something about the code that is using this function if you have a signature. But there is one but here, and the world is not that ideal. And here is how it's not ideal, actually, because if you have outer as a return value for your function, that means that we have to go inside your function body to understand what's going on there, because we need to understand what this outer is actually. And so this function body is not that independent anymore. So we have to check it actually. There is actually some good thing here. So if you have, for example, a decal type, we could try to get some information from it and maybe skip the function body. That's good. But I should say that here is the better solution that we really like. And this is if-const expert. And with if-const expert, I would like to show you one example. So I have here a function get value that actually returns the value if the type is not pointer, and just to return the value under the pointer if it's a pointer type. And here how you could get it, for example, with enable if. So quite a nice code, apart from the fact that the IDE actually has to, when it's actually got the get value call, the IDE has to go to these definitions to see what's going on there, what is this enable if, just unwrap it, parse it, understand what's written there, and select a proper option. But we could hide all this somewhere inside the function, and it could be done with the if-const export actually, because you actually hiding all these details inside the function itself. This, for example, may be not that nice because of the outer return value, but still it's better than the enable if sample and the enable if implementation, because you could like postpone quite a lot of things for the later time inside the IDE and still get some correct parsing. Okay, so that was about the function bodies. So let's come now to includes. Text includes in C++, and they are nice apart from the fact that they are tough. Why they are tough actually? Because first of all, the header file provides information to the parser. If I just took my example that I had in the very beginning and put this template, the foo.h header file, and just have everything in my CPP file and just try to parse it to understand the difference between the last two lines, I actually have to parse the header file. It could be affected by the context actually, and that's the worst thing that could actually happen here. So you have, in this example, these actual lines, they like this line with the X, it could change depending on the value of this magic. So it depends, like the result, if it's a type or not, it actually depends on the actual magic value. And that is not very nice for an IDE because it has to parse the whole header file to understand the difference, to get all these variables values, and to understand what's actually going on in your code. And of course, like that's not the case we have in C++, like in Java when we have import, and at the same moment we know that yes, we're importing this class with this interface, we're fine, we know what symbols has actually come to us. We don't have this with the text includes in C++ and C actually. So, and the situation got worse because in C++ code, this parsing of these include files actually takes most of the time. So they're quite big, they are often included, and most of the time you're just parsing them. So if you just imagine the simple program that is just some, for example, printing hello world to the screen. So you have this kind of include, you have this very small main function, And if you just run a compiler, so most of the time the compiler will be just going for the symbols from this include file actually. And we have to do this as well, like we have to understand what is there. And also, so some same headers could be used in multiple translation units, and sometimes we just run into a situation when we're just parsing them many times in a row and trying to apply all the context, all the variables we have to see all the combinations. So what are the good ways to deal with the includes? The first good way is, from my point of view, is the precompiled headers. Precompiled header files, they are nice because first of all, they save time on the compilation. And so you could just compile once and use as many times as you want. And actually, from the point of the IDE, they're also nice because if not dealing into lots of technical details, we could build some kind of very lightweight symbols from these precompiled headers files, and we could use them, so not building the full abstract syntax tree, but just get some useful information that we could use to parse the rest of your code with the help of these header files. And it's nice just to build it once. But of course, like we could not afford precompiled headers all the time. There could be cases when it's not just applicable. And if you think more, so actually global includes are much better than the local includes, because the local includes is it's highly affected by the context. It's like included somewhere in the middle of your code, and we have to take all the context around it at that very moment when we get there and just try to parse this whole header file with all this information. And if this file is included in the other context, we have to do the same, but with another piece of information. Of course, there are lots of tricks for the IDE creators that they use to overcome the situation. They do many things. They do different caching. They try to postpone whatever they can, trying to build many different contexts, whatever. I'm not going like dig into it here deeply, but still that is an issue with local includes. And of course, ill-formed includes are evil here. And first of all, I think that such kind of code is really unreadable, because if you look at the header file like that, you just like, what's going on there? What's that? And it's not very nice to have this kind of codes in the IDE. Yes?
I stand if someone is doing something like that,
kill him? Yeah, probably. Yeah, probably. So yeah, I would really say that just don't do that. So it's really evil. But sometimes it is more or less necessary. So I saw many projects that is actually doing these kind of things, and they couldn't overcome, at least at that point when they were doing that, they couldn't overcome the situation. I believe now they come with some modern features. They could do some better stuff, with better work, but such code exists actually. And as an IDE creator, we couldn't just say, okay, just don't use the tool because you are providing such a code. But there is actually one thing that I'm really excited here about, and this thing is actually modulus. Because what the modulus means for us is that you got something very close to what I was showing about Java. Yeah, you have the model, and you actually have the information about which symbols is going to be imported. Like what symbols are coming to your code. So you have these kind of functions, you know what's going on there, you have the signatures, and if you are lucky enough, you don't have to parse the function bodies, and you just take this information quite quickly and parse the rest of the code having this information. So that's actually why we think the model is a very good thing, and I really hope it comes to the language. So talking about how the language could help. So as I said, like the modulus that could save us from just plain text includes, if-const export that could save us from some hard to parse code and concepts as well, and actually C++ core guidelines. And I would like to have some more thoughts on the C++ core guidelines, because what I'm really excited about C++ core guidelines is that they are doing lots of great stuff, and they are just pushing the readability of your code with many rules they have. So just trying to help you to write the code that is readable and thus maintainable. They are pushing somehow the precisely typed code in the very accurate way. So it doesn't say that just use types everywhere, but it says that just use concept except on the outer when you can. Just do these things like make interfaces precise and strongly typed and all the rest. And from IDE perspective, these are really great suggestions because it provides us all the necessary information to parse the C++. And it's doing actually many other good things like reducing the side effects in some way, and of course pushing concepts, at least to what is happening in the template section there. So, and talking about C++ core guidelines, so as I promised, I will show some real screenshots from the IDE. This is actually the point when I'm going to show them, because being so in love with C++ core guidelines, we finally decided to add them to C-Line, and we just integrated the Clang tidy tool into C-Line. And so if you now just run the C-Line and got your code there, you'll see all these warnings highlighted on the fly, and you could apply the quick fixes for the Clang tidy. So it's not released yet, but the public preview is available, so you could play around if you're interested. And for us, it's a very valuable step because we understand that we need to help people to follow the rules, because as I said, core guidelines means nothing if you don't have tools that support them. And so that's why we try to do at least this step for now. And hopefully people will be creating more rules, and Clang tidy is actually very nice in terms of adding your own checks into it, and will provide a way for users just to get their checks also on board of the tool so that they could just implement them and got them in the tool. Okay, so let me now spend some time talking about the C++ ecosystem, and that's not about the language itself, but about the tools around the language and some inheritance, some things that we have here for quite a long time. And I will spend some time talking about these 5 points. And if we start with the build systems, we are actually lucky we have lots of them. So we have CMake, we have makefiles, we have auto tools, we have like MS-build, we have QMake, we have whatever we have. Really a very long list. And I just try to analyze how for example, this very simple metric that's called Google Trends, if you know about it, just the number of Google requests about one particular thing. So if you see, so the interest is quite stable. It's growing during the last 5 years for CMake, but in the whole, it's really quite stable interest in each build system, and that's great. That means that they are like, the people need them. And so there is really a huge list. The problem that we actually met when we started with the tool is that all these build systems are not convertible into each other. So you don't have good ways to convert, like you have for CMake, but mostly because it's not a build system, strictly speaking, it's a like generator. And so it could provide you like Visual Studio output, it could provide you Xcode output, and like many others. But if you take, for example, makefiles, you couldn't easily convert them to, for example, into CMake. And you couldn't convert like many other things into each other. And that's the problem, because you either have to support all of them in your tool, or you need to find some way to still to convert them, or you are actually end up in creating your own build system and convert others to your own. That's just one more point on the list that may be also not a very good solution in this case. And the second point that we actually encountered here is that if we look at this build system from the point of the IDE and which information IDE could get out of the build system about your project, The problem with the currently existing build system for like C++ code is that there is no common API, and sometimes the things that you could get out of one build system, you couldn't get out of another build system. And you have either to contribute to it or to find some workarounds or whatever, and that could be somehow a pain here. If we talk about compilers, so there is also quite a valuable list, and the compilers are actually evolving quite quickly, I should say. So they are catching up with many features, and sometimes they are catching up with the features that are not in the standard yet. For example, like the concepts, as they are like now supported in the GCC, and it's the work in progress for Clang. And this all is good, but what problems we actually met here is that compilers are evolving at different paces. So they are actually different. So they are taking different features to implement first. They are sometimes having them implemented differently. And why this is a problem? Because actually, from our point of view, the IDE has to behave the same way as the compiler you are using. So if you are using GCC, we can't pretend in the IDE like doing things like Clang does, because you will be compiling your project with GCC. So we have to somehow emulate what GCC is doing here. And so we have to follow these differences in different compilers and to have them on board. And actually, there is also a problem about the common interface, because the one thing we actually met was when we tried to get the compiler predefined macros list from the compiler. We actually find out that we could do this for GCC, we could do this for Clang, we could do this for Intel, and there is the same actually line call with the same arguments to do that for these three. But if you take the Microsoft compiler, you couldn't do that easily. There is actually two ways to collect different sets, and if you unite these sets, you get the proper set in the end. But still, so this is the issue, that they don't have like general API to get some general things out from the compiler. So I won't be talking much about unit testing frameworks, because just there is a very, very long list, and I was impressed that you probably know that Wikipedia is maintaining this kind of list of tools per language. And if you open the list of unit testing frameworks for C++, you would be really impressed. You could scroll down through the big, huge list, and you will be like, wow, there are so many things on board. And that's really great. They are different, but that's okay. So that's not the tool that should be very similar one to each other. They are solving different problems. They are for different types of work to be done. So just the issue is that sometimes there are too many of them, and you're just a little bit lost in all this list. If we talk about code formatting and in general about the code styles, so you could notice that for C++, you also have a big list. And when I'm actually talking about big lists, there is like, when I was involved in iOS development and the tools for iOS development in JetBrains, I noticed that they had a very strict standard. So they have code style provided by Apple. They have like Xcode and the way Xcode behaves, and everyone just asks to do the same as in the Xcode. And so that's one way to go. So they have just these standards built from stone, and everyone is just following them. And they have one build system, like one compiler, one code style guidelines, and that's it. For C++, we have many. And actually, if we're talking about the code styles, there are really, really lots of them. The story is that sometimes they are not also not convertible properly one into each other, because quite often they are talking about different things. So one code style is like showing you how to do these things, and one code style is covering quite another list of problems. And so you could not just convert one into each other, because they don't have this pieces like the whole common piece. And this is somehow a tricky, interesting problem, and I would like just to share the thing that I really like what we've done. We've done some kind of a hackathon project in the past, that was just taking the code style settings out of real code. So you just give it a real code that is following these somehow some code guidelines like these code style guidelines, and this tool was just taking all the settings out of this code and just getting you the list of settings and how they should be for you just to follow these code styles. And this is really great because you could, after that, you could actually extract the real code style and have it on board of the tool. So, okay, that was about the code style. And yeah, one thing actually I have to mention here is a Clang format. Because Clang format is really nice. It provides you an ability to format with different styles. It has different options. And apart from the fact that we have our own formatting tool, I still think that the Clang format is very nice. And we're thinking maybe about having it on board as well, or somehow converting it to our own thing. But just the Clang format is a good way to have some common code formatting on your project. And the last point was about dependency manager. And like a couple of years ago, when we're talking about dependency manager in C++, there was like nothing in the world. Like we have 30 years of C++, and we don't have anything like that. And for the people that, for example, came from, I don't know, Apple world or like Java world, they're like, what? You don't have it? How you live, actually? And you're trying to explain that, so we have this kind of binary compatibility problems. We couldn't just get some binary and link it. The flags could be different. Like, for example, if you check the list of frequently asked questions on the Google test pages, at GitHub, they have this kind of a very popular question about if I could just take the binary with Google test, link it with my project and use it. And they just say there, don't do that. Because the flags that are used for compiling this piece of code, they could conflict with the flags that you are using for your project, and you could like meet some problems. So please don't do that. Just take this, the whole bunch of code, put it into your project, compile it with your project, and be sure that the flag set is the same. But I believe that quite often we are just, what we do, we either more or less can cope with the binary compatibility issues, or even more, we have just one thing that we would like to compile once and to share with the team, and we are pretty sure that we've done it in a proper way. And we would like to have some package manager that will help, for example, my colleague just to like press the button or write a command that will just take this piece of compiled code and just link it to the project. And right now, I could say that I'm happy that we have Conan, because it more or less tried to solve the issue for us, and it provides this kind of experience to C++ developers. So we still have to think about all these things. We have to to take all the sources to our machine, to compile them, whatever, but at least the problems could be solved, and we could get this experience that is quite smooth when you just type a command. So like saying, so Conan, please get me this library, and it will get the job for you done. And this is a really good thing that we didn't have for many, many years, but currently we are at least on the way of getting these kind of things. So this was about the ecosystem for C++ actually. So just we talk about all 5 here, and that's how the C++ world actually looked to us. So that's it from me. And if you have any questions, I will be glad to answer them.